During the late Cretaceous period, the top predators of Asia and Western North America were the Tyrannosaurids. They were specialized bone crushers, with heads so large that their arms became tiny to compensate. Besides their raw power, most Tyrannosaurids were also built for speed when compared to similarly sized carnivorous dinosaurs. A major exception was the namesake member of the tyrant dinosaurs, Tyrannosaurus rex. The terror of Western North America at the very end of the Mesozoic era 66 million years ago, Tyrannosaurus rex has been seen as the undisputed apex of Tyrannosaurid evolution. The largest specimen, nicknamed Scotty, measures 13 meters long and is estimated to have weighed over 8 tons, making T-Rex perhaps the deadliest terrestrial carnivore to ever evolve. A few theropods, mostly Carcharodontosaurids, had a similar length and height as Tyrannosaurus rex, but they lacked its sheer bulk. And for over a century, no other Tyrannosaurs were known that could compare with the Tyrant King. That was until the beginning of 2024, when saw the description of a new species of Tyrannosaurid with a length of 12 meters, the size of an average adult Tyrannosaurus rex. Named Tyrannosaurus mcraeensis, this new, giant predator belongs to the same genus as the Tyrant King itself. Its fossils are from the Hall Lake Formation, which belongs to the McRae Group in New Mexico. Tyrannosaurus mcraeensis' name, which means tyrant from McRae, is directly derived from this site. There is a misconception that mcraeensis is spelled with one E, when it should be spelled with two. This is how it is spelled in the description, and the two E's belong to different syllables. As another side note, when the description of Tyrannosaurus mcraeensis was published, some confused it with a soon-to-be-described Tyrannosaurid nicknamed Alamotyrannus. Part of the confusion was because the Alamotyrannus fossils, including this one here mislabeled as Gorgosaurus, originate from the Ojo Alamo Formation, which is also in New Mexico. It should be noted that when this Tyrannosaurid is described, it will not be under the name Alamotyrannus. As for Tyrannosaurus mcraeensis itself, while the Hall Lake Formation its fossils are from was once thought to date to the time of T-Rex and other classic dinosaurs such as Triceratops, the Hall Lake Formation is now thought to have been about 5 to 7 million years older. While less iconic, the fauna from the northern half of the continent during this time is still very well studied. But the fossils from the Hall Lake Formation are not nearly as abundant or well preserved, which unfortunately extends to the only known specimen of Tyrannosaurus mcraeensis. It consists of little more than a partial skull, the most notable bone being a mostly complete dentary. The McRae tyrant's fossils were originally excavated in 1983 and described in 1986. While there was some initial debate surrounding their identity, it was generally accepted that they belonged to T-Rex until the new paper published in 2024. The authors, including famed Tyrannosaur expert Dr. Philip J. Curry, re-examined the Hall Lake Tyrannosaurid after finding more of the skeleton, and concluded that while the bones did belong to Tyrannosaurus, they did not belong to Tyrannosaurus rex. The notion of a second species of Tyrannosaurus may sound confusing to some, as Tyrannosaurus is commonly treated as a species. However, it is actually a genus, the taxonomic unit above a species. Leopards, snow leopards, lions, tigers, and jaguars, along with a number of extinct species such as the American lion, all belong to the genus Panthera. Likewise, horses, donkeys, and zebras are modern representatives of the genus Equus. The scientific names of all species consist of a genus name, such as Tyrannosaurus, followed by a species name, such as Rex or mcraeensis, with a unique combination for each species. Most dinosaur genera are monospecific, meaning they are only known from a single species. This is because the differences between species are smaller than those between genera. Without a large sample size, and all too often complete skeletons, it can be difficult to determine whether the differences between two specimens mean they are separate species, or if they are merely the result of individual variation. Another dinosaur that was not monospecific is Tyrannosaurus rex's famous opponent, Triceratops. It consisted of two species, Triceratops prorsus, and the geologically older Triceratops horridus, which had a longer snout and shorter nasal horn. The non-avian dinosaur genus with the most species is the primitive ceratopsian genus Psittacosaurus, which contains 12 species. Still, outside of scientific papers, most non-avian dinosaurs are referred to solely by their genus name. Tyrannosaurus rex was the most notable exception even before the discovery of Tyrannosaurus mcraeensis. There have been other proposed species of Tyrannosaurus over the years. The most notable was initially called Tyrannosaurus bataar, a tyrannosaurid which lived in late Cretaceous Mongolia and China roughly 70 million years ago, not long before the reign of the Tyrant King. It has since been assigned its own genus, Tarbosaurus, but it remains one of Tyrannosaurus's closest known relatives, and is among the largest and most robust Tyrannosaurid genera known to science. A more recent example of proposed Tyrannosaurus species transpired in 2022, when a controversial paper claimed that the fossils assigned to Tyrannosaurus rex actually belonged to 3 species, the other 2 being named Tyrannosaurus imperator and Tyrannosaurus regina. T. imperator was held to be the oldest of the 3, which eventually split into T. rex and the more gracile T. regina. The traits Tyrannosaurus imperator and Tyrannosaurus regina were initially based on are fewer than those of Tyrannosaurus mcraeensis. The current assumption in the field is that they are invalid. This video will assume the same, in part because the traits which distinguish Tyrannosaurus mcraeensis from Tyrannosaurus rex are the same in both Tyrannosaurus imperator and Tyrannosaurus regina. While barely known from any postcranial material, and not even a complete skull, every single bone in the skull found belonging to Tyrannosaurus mcraeensis differs from those of Tyrannosaurus rex in some way. In the paper which described it, Tyrannosaurus mcraeensis bones are distinguished by a 1 next to the corresponding letter, while those belonging to T-Rex are marked by a 2. The T. mcraeensis fossils also happen to have a lighter coloration than the T-Rex specimens shown next to them. The palatine, which formed the back of the mouth roof, was not as broad in Tyrannosaurus mcraeensis as in T-Rex, and was instead closer to the comparatively slenderer shape seen in Tarbosaurus. This meant that its skull wasn't as wide as the Tyrant King's. This may have reduced the raw power of its jaws. A narrower skull would have also meant its eyes were placed more to the side than in T-Rex, reducing the effectiveness of its binocular vision. That said, its overlapping vision was still superior to most other tyrannosaurids, which as a group had better binocular vision than most other theropods. As in T-Rex, the end of its dentary formed a chin-like structure, but it was not nearly as deep. This resulted in a notably shallower lower jaw. The back of the dentary bone is also unique. In other tyrannosaurids, it is deep and downturned, but in the McRae tyrant, it is instead shallower and upturned. The dentary is covered in scars and bite marks, which based on similar markings found in T-Rex and other tyrannosaurids, are believed to have been made by other T. mcraeensis. Tyrannosaurids are thought to have commonly fought each other over food, territory, and mates, which appears to have been a significant contributor to adult mortality. However, it is also possible they were instead the result of conflict with other species of tyrannosaurids. For the most part, Tyrannosaurus mcraeensis's teeth were similar to those of Tyrannosaurus rex, which were large and robust. However, the teeth at the back of the jaws were more compressed. Additionally, while the crowns of Tyrannosaurus rex's teeth were sharp and pointed, the crowns of T. mcraeensis's teeth were blunter, which matches the conditions seen in the slightly more basal tyrannosaurid Tarbosaurus. T. mcraeensis's tooth count was more derived. As Tyrannosaurus's ancestors became larger, they gradually lost more and more teeth. Tyrannosaurus mcraeensis's dentary contains just 13 rows, which is the same number typically found in Tyrannosaurus rex's dentary. However, there are some T-Rex skulls which contain 14 or even 15 dentary teeth, as in Tarbosaurus. A notable difference, not just from T-Rex, but from the rest of Tyrannosauridae, can be found in T. mcraeensis's prearticular, a bone which forms the back edge of the lower jaw. While those of T-Rex and other Tyrannosaurids were strongly bent, in Tyrannosaurus mcraeensis, the curvature of the prearticular is much more gentle. The prearticular served as a strain sink for Tyrannosaurus rex, but whether its different shape would have affected its function in Tyrannosaurus mcraeensis, and if so, how, remains untested. Likewise, the apex, or upper portion of another bone located in the lower jaw, the splenial, is positioned further back than those of other members of Tyrannosauridae. The splenial apex of both Tyrannosaurus mcraeensis and Tarbosaurus were triangular, while Tyrannosaurus rex's had a rectangular shape. A difference from its more famous cousin that would have actually been visible in life can be found in T. mcraeensis's post-orbital bosses, horn-like bumps that were positioned over its eyes. Compared to T. rex, the post-orbital bosses of T. mcraeensis are less prominent and positioned further back. As mentioned earlier, something the McRae tyrant shared with the Tyrant King was its exceptional size. Based on comparisons with T-Rex, the Tyrannosaurus mcraeensis holotype is estimated to have been 12 meters long. Some news sites claimed it was larger than T-Rex, but while it is a bit bigger than the average T-Rex skeleton, the holotype's bones are still smaller than those belonging to the largest specimens, such as Sue or the previously mentioned Scotty. Its bones are also less robust, so a 12-meter-long Tyrannosaurus mcraeensis was probably less brawny than a 12-meter-long T-Rex. Even if the average weight was a bit lower, Tyrannosaurus mcraeensis is still the only known theropod that can confidently be said to have been the same size as T-Rex. Besides the skull, the only other known bones belonging to the McRae tyrant are chevrons, the bones attached to the bottom of dinosaur tail vertebrae, although they are unremarkable compared to those of T-Rex. To summarize some of the notable differences between Tyrannosaurus rex and Tyrannosaurus mcraeensis, the latter had a narrower skull, weaker chin, shallower jaws, smaller post-orbital bosses, and blunter, Tarbosaurus-like tooth crowns. All of these differences are outweighed by its similarities to T-Rex, which are even greater than those of Tarbosaurus bataar. Although the announcement of Tyrannosaurus mcraeensis received better reception than the proposed Tyrannosaurus imperator and Tyrannosaurus regina 2 years prior, some paleontologists still contend that the McRae tyrant is simply another T-Rex. They also question the reliability of the supposedly older date of the Hall Lake Formation, a topic that will be discussed later in the video. Not helping matters, since Tyrannosaurus mcraeensis is only known from the holotype, it is currently impossible to determine whether or not the diagnostic traits listed in its description are part of a greater pattern, with critics attributing them to a mixture of individual and ontogenetic variation. The authors of the description did consider these possibilities, but concluded they were unlikely. Even though Tyrannosaurus mcraeensis itself is only known from a partial skull, there are fortunately numerous Tyrannosaurus rex skeletons, whose differences have been studied extensively. While there's plenty of variation between individuals, the authors found that the McRae tyrant's unique traits laid outside this variation. As mentioned earlier, with the exception of the chevrons, at least one difference from all T-Rex bones can be found in every bone of the McRae tyrant that's been found so far. A single individual possessing so many unique traits would be odd. For it to just happen to be from a different formation than all other T-Rex, one thought to be substantially older, would be quite the coincidence. Furthermore, the differences between Tyrannosaurus mcraeensis and Tyrannosaurus rex are not random. Several traits, such as its narrower skull and blunter teeth, are present in other, less derived tyrannosaurids, particularly Tarbosaurus. Even if one doesn't consider the differences sufficient to warrant a species-level distinction from T-Rex, they leave little doubt that the McRae tyrant represents an earlier stage of Tyrannosaurus' evolution. As for ontogenetic variation, it is true that some traits vary considerably among tyrannosaurids of different life stages, Tyrannosaurus being a particularly extreme example. Juveniles resembled their more gracile ancestors, but slowly became more powerfully built as they aged. The differences between adults and their offspring are so great that there is currently debate regarding whether some skeletons are juvenile Tyrannosaurus or an entirely separate species of mid-sized tyrannosaur called Nanotyrannus. However, with a length of 12 meters, the McRae tyrant can confidently be considered an adult, so the argument that the differences were the result of ontogenetic variation holds a little water. Instead, the evidence fits the pattern of immature tyrannosaurids, in this case T-Rex, possessing the adult traits of their predecessors. In this case, its last common ancestor with T. mcraeensis. Tyrannosaurus mcraeensis's post-orbital bosses are of particular taxonomic importance. Tyrannosaurid post-orbital bosses are thought to have evolved for species recognition or to attract mates, and such traits tend to be highly variable between otherwise closely related species. It is important to note that one of the prominent critics of the paper that described Tyrannosaurus mcraeensis, Tyrannosaur expert Dr. Thomas Carr, is among the minority of paleontologists who still considers Tarbosaurus to be a species of Tyrannosaurus. This doesn't mean that he is wrong, but the standards for what constitutes a new species or genus in paleontology are somewhat subjective, and Dr. Carr is much more of a lumper than most other tyrannosaur experts. The team that described Tyrannosaurus mcraeensis considered the traits that distinguish it from Tyrannosaurus to be comparable to those that distinguish the species belonging to the Tyrannosaurid genus Daspletosaurus, one of whom was notably named in a paper co-authored by Dr. Carr himself. Other scientists disagree with classifying the McRae tyrant as a new species of Tyrannosaurus for the opposite reasons, believing that Tyrannosaurus mcraeensis is unique enough for it to warrant a separate genus. The authors themselves did contemplate this, and even consider giving it the genus name Tyrannosauridae, which means cruel tyrant, but ultimately decided against it. Although some lumpers and splitters disagreed with their findings, most paleontologists tentatively accepted the conclusion that T. mcraeensis is a valid species of Tyrannosaurus. Of course, given how the holotype is incomplete, it cannot be ruled out that additional differences from T-Rex could be found in any new fossils belonging to the McRae tyrant. Therefore, it may one day officially be called Tyrannosaurus mcraeensis. Despite being older and more basal, Tyrannosaurus mcraeensis is not thought to have been T-Rex's ancestor. It possessed several traits, such as its upturned dentary and uniquely shaped prearticular, that are found in neither T-Rex nor more basal tyrannosaurids, suggesting it had already split from the lineage that would produce the Tyrant King. Still, unless Tyrannosaurus regina and Tyrannosaurus imperator prove valid, Tyrannosaurus mcraeensis is T-Rex's closest known relative. Now that the McRae tyrant is considered its own species, the oldest recorded Tyrannosaurus rex specimens are from the Texan Javelina Formation, although they are fragmentary, so it is possible their owners belong to an as of yet unrecognized species of Tyrannosaurus, or even Tyrannosaurus mcraeensis. Before the McRae tyrant was recognized as a separate taxon, T-Rex's closest known relatives were Torbosaurus bataar and a similar Asian tyrannosaurid named Zhucheng tyrannus magnus. These two taxa were much larger and more robust than most other tyrannosaurids, being outclassed only by Tyrannosaurus itself. It was previously thought that the Tyrannosaurus lineage evolved in Asia before spreading to western North America, which at the time was its own small continent named Laramidia. However, although it is more derived, Tyrannosaurus mcraeensis predates these Asian tyrannosaurids, implying that Tyrannosaurus instead originated in North America. Given its clear absence in the long-studied contemporary formations up north, it seems Tyrannosaurus and its immediate ancestors were initially restricted to southern Laramidia, only expanding northward at the end of the Cretaceous period, with the ancestors of Tarbosaurus and Zhucheng tyrannus splitting off and colonizing Asia sometime earlier. Beyond this, how Tyrannosaurus is related to the rest of Tyrannosauridae is more contentious, and the McRae tyrant has only added more fuel to the fire. Tyrannosauridae is split into two branches, Albertosaurinae, which contains the relatively gracile Albertosaurus and Gorgosaurus, and the more species-rich Tyrannosaurinae, which naturally includes Tyrannosaurus. The rest of the Tyrannosaurines were already larger and more robust than the Albertosaurines, although not to the extent as Tyrannosaurus and its Asian cousins, whose subclade is called Tyrannosaurini, because there clearly weren't enough clades whose name was a variation of Tyrannosaurus. Tyrannosaurus and the other giant Tyrannosaurines have usually been found to be closely related to the northern Tyrannosaurine genus Daspletosaurus. The phylogenetic analysis from the paper which named Tyrannosaurus mcraeensis came to a radically different conclusion, with Daspletosaurus being placed as one of the most distant relatives of the Tyrannosaurians. The megatyrants were instead placed within a group of predominantly southern Tyrannosaurians, which matches the hypothesis that Tyrannosaurus originated in southern Laramidia. The closest relative of the giant Tyrannosaurians was found to be Lythronax. This heavily built Tyrannosaurid lived 80 million years ago, making it the oldest known Tyrannosaurid, which creates a nearly 10 million year ghost lineage between it and Tyrannosaurus mcraeensis. However, an even more recent paper, which both took into account the Tyrannosaurus mcraeensis fossils and included additional Daspletosaurus specimens, upheld the previous hypothesis that Daspletosaurus is the closest relative of Tyrannosauridae. Indeed, it strongly supported the idea that the Tyrannosaurians are the direct descendants of Daspletosaurus, as the younger species of Daspletosaurus progressively became more and more like them. If true, then the Tyrannosaurians originated in the north and then spread separately to southern Laramidia and Asia. Additionally, unlike Lythronax, there's only 1 million years separating the youngest species of Daspletosaurus and early Tyrannosaurians like Tyrannosaurus mcraeensis. That said, as mentioned earlier, there is some uncertainty regarding when Tyrannosaurus mcraeensis lived. The Hall Lake Formation it was found in had traditionally been assumed to have been formed during the late Maastrichtian Age, the last chapter of the reign of the dinosaurs. However, the team which named Tyrannosaurus mcraeensis holds that it is instead about 72 million years old, having been formed during either the early Maastrichtian Age or the preceding late Campanian Age. Supporting this, radiometric dating found that an ash bed not far below the site the holotype was found in is 73 million years old. While nothing above that has been dated, non-avian dinosaur fossils are present over 100 meters above the site, so assuming a similar rate of sedimentation across the Hall Lake Formation would mean the McRae tyrant lived between 73 to 71 million years ago. While perfect consistency over millions of years is unlikely, there are no signs of a major reduction in sedimentation rates, or of an unconformity, a gap created when sedimentation ceased or was destroyed by erosion before resuming sometime later. Still, while the early date for the Hall Lake Formation is better supported by the stratigraphy than a late Maastrichtian Age, without radiometric dating, it is not airtight. The evidence for a late Maastrichtian Age was never very strong to begin with, and a large part of it was the original referral of the McRae tyrant to T. rex. In isolation, its basal features would suggest an older age than the late Maastrichtian, and a tip-dated phylogenetic analysis in the paper predicted an age of 69 million years. While this is younger than the presumed age of the Hall Lake Formation, it is also still older than Tyrannosaurus rex. Other evidence of a younger date came from the presence of sauropod fossils at the site. Sauropods were the predominant large herbivores during the reign of the dinosaurs, but they became locally extinct in North America around the start of the late Cretaceous. This sauropod hiatus ended with the arrival of Alamosaurus, a contemporary of T. rex. It was restricted to the southern half of the continent, and is thought to have immigrated from South America during the end of the Cretaceous period. The oldest Alamosaurus fossils are 69 million years old, which has generally been seen as the point it arrived on the continent. However, the fossils of the Alamosaurus-like sauropod in the Hall Lake Formation are 100 meters above the site the Tyrannosaurus mcraeensis bones were found, so they may not have been contemporaries. Furthermore, there are not many fossils from the American Southwest dating between 69 and 73 million years ago, so it is possible that sauropods may have returned to North America a few million years earlier than previously thought. The only other piece of evidence that the Hall Lake Formation was formed during the time of Tyrannosaurus rex are ceratopsian fossils which were formerly thought to belong to Torosaurus, the only large ceratopsian from the late Maastrichtian besides Triceratops. Following re-examination of the fossils in 2022, it was found they were assigned to Torosaurus solely because they had openings in the frill, a trait absent in Triceratops, but common among other ceratopsians. The Hall Lake ceratopsian instead represents a new genus named Sierraceratops. It was not closely related to Triceratops or Torosaurus, but instead to older ceratopsians such as Bravoceratops and Coelaceratops, once again suggesting an older age for the Hall Lake Formation, and in turn, Tyrannosaurus mcraeensis. Besides Sierraceratops, Alamosaurus, and the McRae tyrant itself, fossils of an armored ankylosaur and a hadrosaur similar to Edmontosaurus, a genus which ranged from the late Campanian to the late Maastrichtian, have been found in the Hall Lake Formation. Although the site likely predates T-Rex, it does share something in common with its home besides the presence of a massive species of Tyrannosaurus, the size of the prey animals. While the word small never applied to the megafauna of late Cretaceous North America, the dinosaurs present in the western portion of the continent during the last few million years of the age of dinosaurs were noticeably bigger, and many are the largest representatives of their clades. The members of the horned branch of Ceratopsia, Ceratopsidae, were typically comparable in size to rhinos, but the late Maastrichtian species were instead around the size of elephants. The local species of hadrosaur, Edmontosaurus annectens, was of comparable size. Despite the heavily armored ankylosaurs having existed for 100 million years, the largest known species is the late Maastrichtian Ankylosaurus. Likewise, another contemporary ankylosaur, the Panopelosaurid Denversaurus, is one of the biggest ankylosaurs that didn't possess a tail club. There were few sauropods who weren't at least huge, but Alamosaurus is among the largest known members of the clade. Even among the smaller dinosaurs, Pachycephalosaurus is the largest known member of the dome-headed pachycephalosaurs, while Anzu is one of the largest known oviraptorosaurs from North America. This pattern extends to Tyrannosaurus mcraeensis' home. With the exception of Sierraceratops, who is still far from a lightweight, all of the dinosaurs found in the Hall Lake Formation are closer in size to the fauna of the late Maastrichtian than to contemporary animals found up north. The presence of the large Edmontosaurus-like hadrosaur is not entirely unique for the time, as a large species of this genus, Edmontosaurus regalis, was already widespread in the north during the late Campanian. However, while Edmontosaurus was a rare exception, giant hadrosaurs seem to have been more common in southern Laramidia. One example is the Mexican lambeosaurine hadrosaur Magnapolia, which lived about 75 million years ago. It weighed 8 tons, even more than the species of Edmontosaurus contemporaneous with Tyrannosaurus rex. Another Mexican lambeosaurine, the Alifrons, may have also been a giant. Although the only known specimen is a juvenile, its skull is much larger than those of other similarly sized lambeosaurine juveniles, implying a much greater adult body size. The Alifrons lived between 73 to 72 million years ago, so it may very well have been preyed upon by Tyrannosaurus mcraeensis. The largest known hadrosaur is the Asian Shantugosaurus, but footprints from the new Mexican Fruitland Formation, which was formed 75 million years ago, suggest the presence of an even bigger hadrosaur. A ceratopsian from the same formation, which is either an abnormally large pentaceratops or a distinct genus named Titanoceratops, was the same size as Triceratops and Torosaurus, and may have even been their ancestor. This explains why Tyrannosaurus mcraeensis was so much larger than contemporary northern tyrannosaurids like Albertosaurus. Large predators require large prey, and only southern Laramidia seems to have had enough mega herbivores to support it. However, it was still home to normal-sized hadrosaurs and ceratopsids like Bisticeratops and Sierraceratops, while such dinosaurs were rare or outright absent across Laramidia by the late Maastrichtian. Although not as widespread as Tyrannosaurus rex, which terrorized all of western North America, Tyrannosaurus mcraeensis seems to have lived in a land of giants several million years before ecosystems like this were thought to exist. Therefore, the recognition of this new tyrant has led paleontologists to not just rethink the evolution of Tyrannosaurus, but the development of the wider late Cretaceous ecosystems. Why the dinosaurs in the south, and eventually the rest of Laramidia, grew so much larger than their ancestors remains a mystery. The paper that described Tyrannosaurus mcraeensis suggested that something may have increased the food supply available to the herbivores, such as higher temperatures or a less seasonal climate allowing for consistently higher growth rates throughout the year. Larger herbivores would have in turn resulted in larger carnivores, Tyrannosaurus being the final result. Whatever the cause, the discovery of Tyrannosaurus mcraeensis has falsified several of the hypotheses featured in an older video on this channel, which explored the question of what allowed Tyrannosaurus rex to become so massive compared to other tyrannosaurids and large theropods in general. One was that it was Tyrannosaurus rex who first became a giant. Its closest known relatives at the time, Torbosaurus and Zhucheng both lived in Asia, which implied that this was also where T-Rex came from. Many of the contemporary herbivores there were larger than was thought to be the norm across North America, allowing for the development of megacarnivores. The idea was that once the Tyrant King arrived in North America, the local herbivores were pressured to grow larger in the face of this new super predator. Not every species could be expected to adapt in time, which would have also explained the lower diversity of large dinosaurs in North America at the close of the late Cretaceous period. However, following the description of Tyrannosaurus mcraeensis, it now appears that Tyrannosaurus was not an invasive species, but native to North America, with the Asian species representing a side branch of its family tree. To add further fuel to this hypothesis funeral pyre, the earliest North American megaherbivores predate Tyrannosaurus. Another hypothesis mentioned in the video was that the rise of Tyrannosaurus rex was only possible due to its expansive range. Late Cretaceous Laramidia was divided into several different ecosystems, and for the most part they were ruled by different tyrannosaurids. However, although late Maastrichtian Laramidia was still divided into at least 3 different ecosystems, T-Rex was the top predator in all 3 of them. The hypothesis was that since the same amount of resources couldn't support as many Tyrannosaurus-sized carnivores as they could smaller tyrants, this greatly expanded territory was necessary to maintain a stable population. Yet despite only occupying southern Laramidia, Tyrannosaurus mcraeensis was already the same size as Tyrannosaurus rex. The video also examined the idea that Tyrannosaurus was able to become a giant because adults had a monopoly on the large predator niche, while Tyrannosaurus juveniles had outcompeted all of the other medium-sized carnivores. The discovery of the McRae tyrant has demonstrated that these underlying assumptions may also be incorrect. During the late Campanian, the coasts were inhabited by the massive crocodilian Dinosuchus, an apex predator about the same size as these tyrannosaurs. More importantly, given how Tyrannosaurus mcraeensis isn't thought to have been T-Rex's direct ancestor, there may have been 2 species of Tyrannosaurus in the region, further reducing the minimum territory required to support a stable population of megatheropods. Other recent discoveries have also cast doubt on the idea that T-Rex itself was the sole large carnivore in its environment. Although Tyrannosaurus imperator is thought to have been its direct ancestor, the proposed Tyrannosaurus regina was envisioned as its contemporary. Given its more gracile build, Tyrannosaurus regina may have focused on smaller prey, or it could have preferred to hunt in denser environments. Furthermore, should Nanotyrannus turn out to be valid, that would mean that juvenile Tyrannosaurus wouldn't have just competed with other species of the same genus, but with a dedicated, medium-sized carnivore as well. Overall, Tyrannosaurus's gargantuan size seems to have been less a result of a unique life strategy or unusual evolutionary success, but was merely a byproduct of it living alongside massive herbivores. Although many other Mesozoic paleoenvironments contained large dinosaurs, they were primarily sauropods, whose populations contained relatively few adults. Compared to hadrosaurs and ceratopsians, adult sauropods were less susceptible to the bruiser tactics of carnivores like the Tyrannosaurids, which were more reliant on a larger body size than the attritional tactics thought to be employed by carnosaurs like Allosaurus. Although published right at the beginning of 2024, the description of Tyrannosaurus mcraeensis promises to be one of the most important paleontological discoveries of the year. Not only is it a new carnivore just as large as the Tyrant King, but it has rewritten the previous consensus of the origins of the Tyrannosaurus genus. It has also revealed the presence of a long-overlooked paleo-ecosystem, one which contained mega herbivores long before the rise of T-Rex. The Hall Lake Formation has been underexplored since fossils there are rarer and not as well preserved as those from previously presumed contemporary sites, such as the Hell Creek Formation. The revelations brought about by the description of Tyrannosaurus mcraeensis may spur more extensive excavation of the McRae Group, uncovering more about this new species of Tyrannosaurus and the animals that lived alongside it. Thank you for watching. If you enjoyed this video, please remember to hit the like button, and consider subscribing if you'd like to see more. If you'd like to support this channel more directly, you can join my Patreon, where you'll have access to polls to select the topics of future videos. Finally, be sure to have a great day.